Hello friends, in this video we will talk about the properties of photons. Okay, this is the very first lesson for you in something which we call as the quantum mechanics, right? So get ready for the lesson, your first lesson in quantum mechanics, and in this video we are going to learn about the photon theory. Okay, first of all, what is a photon? See, we have known this fact that light, sometimes it behaves as small particles, sometimes it is behaving like a ray going from one point to other point, and sometimes it is behaving like a wave. So light is there with us in all three forms. Okay, but at one time only one of the nature is revealed. Got it? लाइट के तीनों नेचर्स होते हैं. एक ज्योमेट्रिकल नेचर होता है जिससे हम रे डायग्राम्स बना सकते हैं, एक उसका वेव नेचर भी होता है और एक उसका पार्टिकल नेचर भी होता है. ठीक है, लेकिन एक समय में सिर्फ एक ही नेचर उसका सामने आता है. राइट? व्हाट इज दैट नेचर इन पार्टिकल्स? दैट इज ए फोटोन. सो हाउ विल यू डिफाइन ए फोटोन? सी, व्हेन लाइट इंटरैक्ट्स विद मैटर, it behaves as if it is made up of small particles. These particles are called photons. I am repeating it so that it gets in your head straight away. When light interacts with matter, it behaves as if it is made up of some small particles, and these particles are called photons. Okay, now what is the energy of light? Energy of light or energy of the photon of light is given by this formula: E is equals to h into nu. H is Planck's constant and nu is the frequency. What is the value of Planck's constant? Planck's constant has this complicated value. In SI unit system, we write it as 6.63 into 10 to the power minus 34 joule into seconds. And if you want the energy in electron volt, because mostly when we deal with atomic and subatomic particles, we do not measure energy in joules, we measure it in electron volts. So what is the value of Planck's constant in electron volt? There is 4.136 into 10 to the power minus 15 electron volt seconds. Although if you read any particular data or the data given in the question paper, they always give this value of Planck's constant 6.63 10 to the power minus 34, but sometimes when you need to calculate the energy in electron volt, I suggest that you also remember the value of Planck's constant in electron volts, 4.136 into 10 to the power minus 15 volt. Now how to calculate the energy of photon? Nu here stands for the frequency. So if I have a light whose frequency is 10 raised to 10 hertz, how will I calculate the energy of that light particle or that light photon? Simply multiply Planck's constant with the frequency. That is this into the frequency. This is 6.63 10 to the power minus 24 joules. And if you want the energy in electron volts, just multiply this frequency with this number. This will give you the energy in electron volt. Here it is 4.136 10 to the power minus 5 electron volt. Okay, third property of photon. See, do photons carry energy? Yes, they carry energy. The formula is given as h into nu. But do they carry momentum? Yes, they carry some momentum. And how to calculate that? We go for the famous formula given by Albert Einstein, E equals to mc square. Now what is E? Here it is h nu is equals to mc square. Bring one c over here, that is h nu by c, and what is left over here? M, which is the mass, and c, which is the speed. What is mass into speed? Momentum. So what is the momentum carried by photon? You can write it as h nu by c. Further, if you want to simplify it, then write c is equals to lambda into nu. Do you know this relation? Very simple relation. Speed of light is equals to wavelength into frequency. If I put this value in this equation, nu will cancel out and the momentum of photon will be simply h upon lambda. Okay, this will be easier if you connect it like this. If you multiply Planck's constant with frequency, you will get energy, and if you divide Planck's constant by wavelength, you will get momentum. Okay, momentum of photon given by h upon lambda. Now, what is the mass of this photon? Because I have called photon a particle, there must be some mass associated with it. You can simply calculate the mass from this equation. H nu is equals to m into c square. So m is equals to h into nu over c square. This is the mass of photon. But there is something else attached to it. Photons do not exist at rest. That means the rest mass of photon is equals to 0. Then what is this mass? This is the moving mass of the photon. What is the rest mass? How to calculate the rest mass? We use a quantum mechanical equation. M is equals to m0 into square root of 1 by v square by c square. इस फॉर्मूले को थोड़ा सा समझ लो. What is m0? Mass of the object when it is at rest. What is m? Mass of the object when it is moving with velocity v. ठीक है, क्वांटम मैकेनिक्स के हिसाब से जब भी पार्टिकल्स मोशन में आते हैं तो उनका मास चेंज हो जाता है. नॉर्मल क्लासिकल मैकेनिक्स में ऐसा कभी नहीं होता, बट दिस इज द कंसेप्ट ऑफ क्वांटम मैकेनिक्स दैट whenever the object starts moving, the mass of the objects will change. So rest mass, moving mass. V is the speed. Now from this formula, इस फॉर्मूले को मैं थोड़ा सा चेंज कर रहा हूं. I am writing this formula for m0. That will be m into root of 1 minus v square by c square. ठीक है, अभी देखो फोटोन किस स्पीड से चलता है. फोटोन ट्रेवल्स विद द स्पीड ऑफ लाइट. Whatever is the speed of light, same will be the speed of photon. So if you put c over here, what you will get? If you put c over here, then the rest mass of the photon will be equal to 0. That means photons do not exist at rest. Alright, next point, intensity of light is directly proportional to number of photons. थोड़ा सा यहां आपको हमेशा याद रखना पड़ेगा, कभी भी क्वांटम मैकेनिक्स में यह गलती नहीं करना. एनर्जी ऑफ फोटोन always depends on only one thing, that is the frequency. Now the intensity of light, on what does it depends? It depends on number of photons. तो if you are looking at a dim bulb, एक बल्ब की तरफ देखते हो जो थोड़ा सा डिम है, कम रोशनी वाला है, तो उसकी इंटेंसिटी कम है. क्यों कम है? बिकॉज इट इज एमिटिंग लेस नंबर ऑफ फोटॉन्स. ओके, इफ यू आर वॉचिंग समथिंग विच इज वेरी ब्राइट, जैसे आप अगर सन की तरफ डायरेक्टली देखते हो, तो इट appears to be very intense. Why it appears to be very intense? Because the number of photons coming from it are very large. So what we write is intensity of light is directly proportional to the number of photons. Okay, now see, photons cannot be affected by electric field or magnetic field. यानी photons पे कोई भी electric force या magnetic force नहीं लगता. क्यों नहीं लगता? Because the charge carried by photons is equal to 0. इसकी इक्वेशन देखो, इलेक्ट्रिक फोर्स की, मैग्नेटिक फोर्स की, दोनों में क्यों आता है, ये थोड़ा सा आपको अपनी मेमोरी में से निकालना पड़ेगा. दैट हाउ टू फाइंड इलेक्ट्रिक फोर्स और मैग्नेटिक फोर्स, राइट. दोनों की इक्वेशन में Q है. सो इफ Q इज 0, नो इलेक्ट्रिक फोर्स कैन एक्ट ऑन इट, नो मैग्नेटिक फोर्स कैन एक्ट ऑन इट. एंड बिफोर आई लीव, I will just tell you one more formula that will be useful in calculation of numerical problems. Power of photons, okay, या power of a light beam is equals to number of photons into h nu. ठीक है, power of photons is equal to number of photons multiplied by h nu. अभी power का basically formula क्या होता है? Power is energy upon time. What is power? It is energy upon time. ठीक है, time, energy upon time. Can you see that top portion where I am writing? Right. Okay, instead of time I am writing frequency. Instead of time, can I write it like this? Frequency into energy. Okay, what is frequency? Number of particles per second. So here instead of frequency I can write it as NE. तो power का formula बन गया number of photons per second into energy of single photons. Right? Now this can be copied down in form of notes also, and you have to learn each and every property. Of course, it is very simple to remember all these properties of photons. Thank you.